But some of this loose matter remains in orbit around the newborn star. Over time, the debris gathers into more knots and clumps, growing and evolving into a planet.
It really is the case that if you could go back 4.5 billion years ago and look at the formation of the sun and the solar system, that it would be that kind of an environment that you would find us in.
Hubble shows us the genesis of a new solar system and answers an age-old question of how our own star, the sun, and our Earth came into existence. Beyond the Eagle and Orion nebulae, even larger star-forming regions lie within the plane of the Milky Way. Scientists wonder if the life cycle of stars is the same in these distant regions. In March 2005, Hubble began relaying images of a new target. The Carina Nebula, one of the largest star-forming regions in the sky. But the raw data sent by Hubble looks nothing like this. Creating images that help scientists unlock the mysteries with this data falls to imaging expert Zsolt LeVay. Picture data comes in from Hubble in black and white. LeVay assigns colors to these images according to the chemical elements detected by Hubble's instruments. Blue shows oxygen. Red shows sulfur. And green is hydrogen. LeVay works for about a year to produce the full mosaic out of 48 separate pictures. The sheer size of this landscape is astonishing. Hubble's image of Carina shows a region over 50 light-years across. Intense stellar winds from newborn stars sweep clouds of gas and dust. Here, too, are the eggs that will one day become solar systems like ours. Among the thousands of newborn stars lurks a surprise. Within the cloudy halls of Carina, Hubble detects the death throes of a massive star. 2005. Hubble zooms into the Carina Nebula. Its images reveal a massive and hostile environment, one that shows stars and solar systems being born. It also shows at least one star about to die. For scientists, a dying star is an opportunity to see the future of our own solar system. What these Hubble images show are shells of gas that serve as tombstones. Their quiet beauty is deceptive. These walls of color are the outer layers of a star much like our sun. As a star runs out of fuel, these layers expand until the gravity of the star can no longer hold them. In time, they drift into space. In 2004, Hubble captures an image that gives us a glimpse of our eventual demise. The Helix Nebula. As these outer layers of a star expand, they leave behind a searing hot ball of solidified oxygen and carbon astronomers call a white dwarf. Someday, the same thing will happen to our own sun. The sun will run out of fuel, and that will cause it to expand into a giant red star. That's bad news. The temperatures on our planet will rise over 1,000 degrees. All life on Earth will perish. a wall of hot gas will sweep over the Earth, through our solar system, and into space. Every planet and moon in its path will be incinerated. The only thing left of our sun will be a splash of color, visible from thousands of light years away, like this.
So the human race has its warning. We have 5 billion years to clear out of town.
But even the death of our own sun hardly compares to a more powerful downfall. Some stars are over 100 times more massive than our sun. The bigger the star, the shorter its life, and the more violent its death. These stars explode in a massive fireball called a supernova.
Not every kind of star can explode as a supernova. The sun can't, for example. It just lacks the oomph. It doesn't have the mass that you need to be able to get what happens in the core to make a star blow up. There are a handful of stars in the galaxy that are definitely capable of doing this.
Every star is carefully balanced between the inward pull of its gravity and the outward pressure of the heat it generates from nuclear fusion. When it runs out of fuel, the pressure needed for balance is gone. Gravity now reigns supreme. The star caves in and explodes. The full fury of a supernova destroys the star and everything around it. One such giant star has already exploded in our own galaxy. Hubble Space Telescope recorded the aftermath.
The Carina Nebula is the expanding wreckage from a supernova that occurred in the year 1054. The explosion of the supernova was recorded by Chinese astronomers, so we know exactly when the explosion was.
The expanding debris from this 1,000-year-old supernova is still moving into space at over 3 million miles per hour. But the image is more than just a snapshot of ancient history. For scientists, the interconnected web-like filaments offer a clue as to the nature of life itself. The basic elements needed to create life are formed in the heart of stars. When stars explode, these fundamental elements are scattered throughout the universe, seeding distant nebula clouds, which give birth to new planets and new life.
The hemoglobin in your blood, when you bleed and it's red, that red color is due to oxygen, and it's due to iron that is in your blood that was created in a supernova. The gold on your wedding ring is created in a supernova. Calcium in your bones was created in a supernova. And so we learn so much about the universe itself when these stars die.
Hubble is giving scientists the ultimate learning experience by monitoring one particular star, Eta Carina, back in the Carina Nebula.
This is a star that is a bit of a mystery. It appears to have about 100 times the mass of the Sun, and that is the upper limit. The more massive a star is, the hotter it is, and the surface of the star is so hot that it can't even hold on to its own gas. It's constantly blowing off a stream of gas.
For over a decade, Hubble creates a series of photos of Eta Carina. The photos show two enormous lobes